Hi, everybody. Welcome back to Soft Magnetics.
Hard topics.
I'm Bridget.
And I'm Mike.
And today we're going to be talking about why didn't my Fair-Rite work? So we're going to go over 5 common issues of why your Fair-Rite didn't work.
Is that even possible that it didn't work?
No. There was only 5. It was impossible. So Mike's going to go over all of them. So the first one we have is wrong material selection.
Yeah. So one of the main things that's going to factor into what material you should use, and when I say material, I guess I'm actually really talking about both. Like, should you have chosen Ferrite at all?
Mm-hmm.
And if yes, what material grade specifically should you have chosen? So frequency is going to be like the main thing that dictates that. And that's kind of the differentiator between any of our Ferrite materials is the frequencies that they're designed to attenuate signals over. So you have something like 75 that's really most effective below 1 megahertz. And then you have materials like 61 that don't really start becoming all that effective until you're into the many hundreds of megahertz kind of range. And then kind of on the low end, there's practical limitations of how low in frequency Ferrite's good for, any Ferrite. There are materials like nanocrystalline that work better down in like the tens of kilohertz, maybe even 100 kilohertz range relative to a Ferrite. But yeah.
And then you kind of covered it. The wrong frequency assumption is number 2.
Yeah, I mean, I guess you can kind of talk about that 2 different ways, right? So you're using the wrong material for the frequency that you're trying to attenuate. I guess the other thing is you can have the wrong assumption about the frequencies you're trying to attenuate. So you may think that you're having a noise concern at 2 megahertz, but maybe you aren't. Maybe you're actually having a noise concern at 200 megahertz, and somehow you got the 2 confused, or the diagnostic equipment that you're using is not picking up, accurately the signals that you're trying to attenuate or find. So you could be chasing the wrong material, even if what you chose based on the data you had was right. You have to make sure that the data is right.
Right. And then number 3 is too few turns.
Yeah, so that becomes more of a concern down at lower frequencies, or for something like a common mode choke where you're winding to like a specific inductance value. Talking about it kind of in simplest form of just low frequency suppression. So most of that suppression comes in the form of inductive reactance. That's a function of the permeability of the material and the air core inductance of the geometry, and then also the number of turns as a kind of exponent multiplier to the base impedance value. So you can wind up with a scenario where maybe you need 200 ohms of attenuation, and the part that you're able to use, be it a size constraint or just availability of parts in general, only produces something like 30 ohms. You can get up to that 200 ohm needed attenuation level or needed impedance level by adding more windings through the core. So the impedance ratings for a core are always single turn. So you put a wire through it once at that frequency, that's the impedance that you're going to get. But with each additional turn that you put through the core, you're going to increase that impedance by the square of the number of turns. So 4x for 2 turns, 9x for 3 turns, and so on. Up to a point, actually. You can have too few turns. You can actually have too many as well. So at certain frequencies, you can actually start going backwards because of the capacitance you're adding per turn. So you can have too few or too many.
Just right. Okay, so then the 4th one is placing the Ferrite in the wrong spot.
Yeah, so that a couple things could be going on there. So you can have, for conducted emissions, you could have simply the Ferrite on just the wrong line. Radiated, it gets a bit more interesting. So for radiated emissions off of a conductor, what you're doing in essence by adding a ferrite core to it is you can, in some scenarios, make tuned antennas with the ferrite core out of the conductor. So what you might be doing by putting a conductor or a ferrite halfway down a certain length conductor is you might be producing a tuned antenna. Since now you have a high impedance in the middle of that conductor, you made two shorter antennas essentially out of that conductor by putting the ferrite in the middle. And that could actually tune that conductor to act as a better antenna at certain frequencies. So you may actually shift the radiated noise that you're seeing. You may increase the radiated noise that you're seeing. Usually the safest option is for radiated emissions, put it as close to the source as possible. And that'll, the shorter you can make that antenna, essentially, the higher frequencies that concern get shifted out to. For conducted, you may need to do something like building a makeshift. You can actually use Ferrite for this, makeshift current probe. See what sort of frequencies the current is and actually isolate it to specific lines if that is the concern.
And then the fifth one we have is the common versus differential mode confusion.
Yeah. So you can have, and I think we have another video on this that we can probably link.
Yeah.
I think we're sophisticated.
Yeah, I could copy and paste.
Cool. So we have another video on that explaining it in detail, but I guess just as a quick overview, for common mode EMI, if you think about it in like simplest terms, a positive and negative conductor, just coming from a DC power supply, the common mode EMI is going to be noise that's conducted in one direction, in the same direction, down both the positive and negative cables. Differential mode would be noise that is, kind of as the name suggests, down one cable in one direction, and if it comes back through the other cable in the other direction. What happens essentially, if you have common mode EMI, using a ferrite differentially, so on each line, will get rid of that EMI as well. But a common mode core over both lines at the same time, so you just have one snap-it or one shield bead with both cables going through there, that's going to also attenuate that noise. Now, if you have differential mode noise, adding a common mode core over both lines actually isn't going to attenuate it. The noise will cancel itself out differentially in the core, and that won't see any of the impedance from that core. I guess this is the fifth one, but we'll add a sixth.
Oh, bonus.
Yeah, going off script.
bonus round.
And it's kind of related to that common and differential mode operation. So if you're operating in differential mode and you have also high currents in your application, that can actually degrade the performance. Well, I should say that will degrade the performance of a ferrite core as well. So you may see only 30%, 20%, 50%, depending on the frequency and the amount of current of what that impedance value of the core should be. So that'll degrade it quite a bit if there's a high current. You don't have to worry about that for common mode, but differential mode, that is a concern, and that could be one of the reasons the core is not performing quite as expected.
Mm-hmm. So as our ferrite expert, what's the top one? If someone's ferrite's not working, where would they start? Which one do you think?
Make sure that the material's correct.
And if they messed up all of them, just call Mike.
Yeah. I don't know if we'll be able to help if everything on that list is wrong.
If all 6 items.
We'll try.
If all 6 items are wrong, just call us. All right. Well, is there anything else that you want to cover and tips, tricks, why it might be not working?
I mean, if you could, the more you can learn about the application, we also have folks in the ferrite cores that just wind up in applications because I tried these 10 things and this one worked.
Right.
It's a valid strategy. It just takes longer.
Yeah.
But yeah, I mean, as much information as you can get about the application, we have a lot of information on our website that you can use. So,
Yeah.
Get as much info about the application, bring it to our website,
Mhm.
use our resources that we have there on selection criteria, and
Right.
all that kind of stuff, and hopefully get you pointed in the right direction as quickly as possible.
If not, call Mike.
If not, call me.
All right. Well, thanks for reviewing that with us, and thanks for joining us. If you want us to go over any topics, feel free to comment, and we'll see you soon. Bye.
Bye.